Hello everybody. How's it going? Welcome to Composing Test Generators. My first question out there, who here really loves writing tests? Surprisingly, not many of you. Unfortunately, no. So that's really interesting because I hate tests as well. And I still don't love them, but through property-based testing and writing generators, I'm kind of starting to like them to some degree. So who I am Zeeshan Lakhani, a programmer at this amalgamation that is Beatport, SFX, and ARC90. I'm also the lead organizer of Papers We Love, which if you haven't went to one local chapter in your area, please do so. I also, when I was writing this talk, I was listening to this album, which maybe made me go crazy because this whole talk is in Emacs in org mode. Good luck to myself to see if this all works. All right, so we're going to cover a few things. We're going to cover just some background on tests, a little bit of history behind property-based testing. We're going to talk about data generation from a validation layer, so it's how we use testing. The stuff that I'm talking about is some stuff I do at work, which is in Clojure. So we're talking about actually generating data from another layer, and this is all in runtime. And then that leads into the case study that we do have, which is actually talking about how we use property-based testing to test our web services. There is another talk about property-based testing that I think would be the more definitive one, and that will be tomorrow here at the conference by Jessica Kerr. Okay, so when I started started being told that I have to do TDD testing, it was a couple of years ago. And the same way I kind of got into programming, I just ran with it and did it, and just kept working at it, hoping that I would write enough test cases to cover everything that I needed. But I didn't think. And a lot of the people I worked with, and a lot of people in general, they don't always think about when they do tests. So the way I've approached programming and anything in general, any problem in general, is I think about a hammock. This is actually an actual link on Rich Hickey's Clojure bookshelf, the creator of Clojure. So he actually links to a specific hammock. And the concept of hammocking, I think, is this great thing where you have to actually think about your problems before you attempt to solve them. And I think what's come out of this property-based testing is that that's kind of almost the main point of it all. Here's another great image. This is John McCarthy, creator of Lisp. And see the way he's looking at the computer right there? It's really great because he looks like he's enjoying the dialogue with the computer. He's playing chess with it. He's enjoying it. I have never looked at a computer this way. There's much more anger, animosity, especially when I'm writing tests. It's the worst. So I dream one day to have this. I really do. So we talk about the beginnings, software testing. This is the book by Glenfield Myers in 1979. I have not read this book. Anyone else has? Good for you. I'll skip through. And I'll talk a little bit about what this talk is based on, which is quick check. We use a Clojure implementation by Reed Draper that's part of Clojure Core now called test.check, and I'll talk a little bit more about that. But this is the original paper from circa 99, 2000. Highly recommended. He also had another one about fun and profit, John Hughes, and I guess what I do every day is write tests for fun and profit. And there's more recent stuff. There's a lot of work with quick check and Erlang. And they're doing stuff with finding issues, actually testing race conditions, which is a major problem. I'll cover a little bit about that in this talk, but not too much because the Clojure library doesn't have that yet. Okay, so from the original paper, there's a couple great quotes that I think define property-based testing, the way they explain it in quick check. So we have designed a simple domain-specific language of testable specifications, which the tester uses to define expected properties of the functions under test. So we're talking about a DSL for testable specifications. And the idea is that to look at the tests that you're writing as specifications for your programs instead of anything else. And they have said, we have chosen to put distribution under the human tester's control by defining a test generation language, which is what I'll be talking about and showing you examples from. And they kind of conclude toward the end that we have taken two relatively old ideas, namely specifications as oracles and random testing, and found ways to make them easily available. They say Haskell. All these implementations exist now. There's even a JavaScript version of this, which lacks some things, but Douglas Crawford worked on it, so it must be one of the good parts, I imagine. So, And from another paper, this is a kind of good idea to put it. The idea of property-based testing is to write a specification of the system under test in a suitable language, which is then tested using a large collection of test data invented by the computer. And I'll show you how. Now, see, the way we've been testing beforehand, or before property-based testing, is we're just always testing. John Hughes, in one of the talks I saw him do, gives this idea. He has a great little face. I don't have that here. But, usually when you have a feature that you're implementing, one feature, 4 or 5 unit tests, everything seems pretty good. You're having a good time. You're moving on to something else. But then, a new feature comes around. This feature works with that other feature. So now you have to write more and more tests. And actually, the time we're talking about is actually quadratic here. And then you have another feature that's working with another set of features. And we're starting to, everything just starts growing and growing and growing. And it becomes a mess. And especially if you're working with a lot of mutable programming languages, the mess can go super deep. And you may never come out. I mean, one of the projects I did where we did a lot of unit tests, a lot of mocks, I think we spent at least 1 day a week just on writing tests, like that amount of time a week, which is actually, I think, way too much. So testing has gone through a lot. There's a lot of hoopla about testing. This guy said that TDD is dead, which he may be right. At the end of the day, I just don't care. That's my whole thing on it. So he drives a race car, though. So, and I don't, I've never was I did it. I've done my share of Rails stuff as well, and TDD, and we did TDD on various projects, and it's fine. At the end of the day, I just want to write all the tests I can to make sure my things work and that I'm not responsible for, terrible problems. And actually, property-based testing has helped that. But we've seen through all the different things you can do, and one thing I'll show is even an example of some of our tests, or one of our tests before we started using property-based testing. But these are all the definitions of all the things we've used. It's hard to even keep track. Though itself, property-based testing does have some, it matches some of the criteria you might see in integration and regression testing. I mean, actually, we kind of test regressions through having to run constant generations all the time. So that's really helpful. But here is an example of a test that we were running beforehand. So this is in Clojure. Hopefully it makes sense. Mind the parentheses, of course. So we were just testing, we're doing web services. So we're just testing a post here. It brings a system state. And then here, if I go down here, this is our set of dummy data for a specific resource that we're posting to. And it's like slug, name. But see, we had a couple of these tests, like maybe 3 or 4 of these. And they all passed. They always do. And the reason they do is because, maybe you have a variation. There's like optional fields that are not in this specific example that this resource can take. We maybe have a couple more separate tests that do that. But, we're not testing how long a thing is. And we have a validation. We have validation. Every request goes in through validation. Maybe our validation layer is wrong as well. But we can't really test that because we know this little minute, like dummy data test here will always work. And this is the problem that we've come to test. Tests are normally full of bias, laziness, and redundancy, and they get tedious because you end up having to start adding these tests over and over and over again, and it's not really fun. And I'm part of this. I'll blame myself as well. So, all right. So, property-based testing specifically is this idea of establishing invariance in code. That I have this concept, this thing, the specification that will not change, and give me all the things that I test all the things possible against it. And actually, a better title for my talk that I would have named later is this idea of generating circumstances. So all the data that we're generating, it's not just data, it's circumstances. You could say it's all the edges, all the cases, but circumstances I thought was really good and a more holistic view on what we're doing. All right, so some examples. So here's a very simple one. So I'm going to talk a little about generators, and I'll talk about our use case. So the idea of a specification here is that for maybe linear algebra days, I don't know, I forget when matrices came in. But the idea is that the transpose of a transpose matrix is the original matrix. So I have that here. So we're going to run this. Okay, so, and I did. What this generator is doing here is saying that I can't have an empty vector that is made up of, I'm doing all 3 by 3s here, right? Or it has to have 3 integers. And these are a little weird. I'm using a Clojure library called core matrix. But if you can think of this is an example like a 3 by 3 matrix, just stacked up, 3 rows this way, 3 columns that way. And it goes on. I have 10 samples. That's what the 10 means in gen sample. Okay. So, and what property-based testing does, when I hook this in, I can actually give that a huge number, and it will generate, it would create a test, a test for all these generations that occur. So just in case you forget what a transpose matrix is, we have that right here. So I have this matrix 1, 2, 3, 4, 1, 3, 2, 4. That'd be the transpose. So now I want to write a test. So my simple test, my simple specification here that should always be true is that for all the matrices that I come in here, that the transpose of the transpose matrix will be that original matrix. And I'm going to do this over 50 generations. So I run this, and the result is true. This is true. And I ran 50 tests. And I'll show you what failures look like in a second as I turn off my volume. Okay. All right, so let's talk another example. This is from the Closure Cookbook, actually. I thought it was pretty good. It's about failure and shrinking. So I have this idea of a reciprocal sum, just to make sure to show you an example of what that means. So if I have 1 over 1, it'll be 1 again, and then 1 over 2, so it's 1 plus a half, gives me 3 over 2. So now what I'm going to do is I'm going to generate a set of numbers that are all even, that are just another sequence of these that we're going to sum up eventually. So I generate this sequence here. So you see all these sequences. Let me do this one more time. All right, cool. And if I go down here, now I have another test for all of these numbers in each one of these sequences. Is the sum a number? Very simple test. They should always be numbers, right? This should definitely pass. I think it should. I don't know. But it doesn't. And I run this over 100 times. And you see here the failure. This is a very simple example of shrinking. But if you see here, you'll see that I have, I'm going to run 5 tests. I have this failing size of 4, and my failure was at 0, -4, and -2. And what this does, though, is that's a very simple case, and I can see the problem. I can't divide by 0. That cannot happen. That reciprocation will never happen. So, but this is a very small use case. But actually, a lot of the property-based testing frameworks, variations of quick check, have the ability to shrink the algorithm to the smallest failure case. The Closure one has this, as well as the Erlang and Haskell ones, and I guess the Scala one as well. I'm guessing some others. So if you see here, smallest gives me 0, because the base case would be 0. A sequence of just 0 itself will definitely fail, because you can't divide by 0. So when we're dealing with larger data sets, like what we're dealing with like big request maps that we're dealing with, and we're generating data that something can have a vector with 800 elements, I can't really see where the failure might be. But when I look at the smallest cases, I can actually do that, and that's really great. I'm only going to briefly go over concurrency here, but there is some stuff being talked about for Closure specifically to allow for testing against race conditions. I mean, let's be honest, this is the, testing against input is great, and that's a huge component of it, but when we're talking about distributed systems, the hardest thing to deal with is when something goes in a queue and it gets removed, but yet it comes back later, and you're dealing why is this there? Why is this there? There is some work being done with this now with the test-check implementation and some of Kyle Kingsbury's work with Gnosis to find concurrency bugs and verify linearizability. And there's some stuff being done where Reed Draper's doing where he's trying to using this with readefs function to redefine Closure concurrency stuff to actually say, can I actually give it a random scheduler to actually randomly schedule things and see if they came back in some order. Glossing over it, but they're all linked, and this presentation will be an org file and the PDF that you can get to. Okay, so specifically for a lot of the cases that we're dealing with, we do have this validation layer on top of all the stuff we do for our web services. And you can say they're kind of like our types. We keep them very separate. They're not part of everything else in our code. We stay dynamic otherwise, and this is runtime. And we use a library from a company called Prismatic called Schema. And this is what a schema looks like. And if you take a look at this, we have a map with these certain keys and a possible option key. Schema has a lot of its own tools to validate. So I can actually run this here. And I get back the original map, and that means it did validate. That is good. But if I look at this right here, I'm looking at the same thing. So look at data is the schema that I'm validating against, and I'm throwing it again this value right here. And if you look at this, I'm missing something here. I don't have Baz. Pirate I have, but that's optional. So I run this, I see that Baz is a missing required key. So Schema does this. It's very nice. It's very helpful for us, especially because we're dealing with a lot of clients using our services right now, and it's like we have to make sure that they know what data they can push in and what data they can't. All right. So we wanted to, we were talking about like how to do better tests. We just came back from a conference. We saw John Hughes give a keynote about quick check, and we were like, our tests suck. Actually, guys, our tests are terrible. And we're in a very fast and loose, is what my boss would say, fast and loose environment, which is true. We're always having to change features, change sets. Our designs are always changing. And that's going to consistently happen going forward. That's not going to change. So one thing we thought was, okay, still good to have unit tests, still good to have certain things that we're testing, because it does help you kind of make sure you're writing the right implementation initially. But we want to say, what are all the edge cases that we're forgetting about? What are all the circumstances that our data can have? We have various clients. What are all the inputs they might give us? And is our validation checking that? Are we letting things through to hit the database? That could be really bad. So based on some work done by Prismatic people themselves and some other people, I created a little library that we use at work called schema gen. So I'm going to show you an example of that now. So here I'm defining a schema for a vector that says I have to have the first element as some sort of Boolean. The second element has to be a Boolean as well. The third element might be an optional maybe. And if that element does exist, give me a bunch of integers. So if I run this now, and I'm sampling this in 10 variations, you see that I'm going to get 10 different vectors, 10 different sequences of a Boolean right here. I think I said that wrong initially. Keyword, sorry. So a Boolean keyword. So Boolean here, and a keyword map, which you see here. In this case, if you look at one of the integers right here. So I have a Boolean, I have a map with a keyword and a bool, and then I have an optional keyword, and then I have random integers. So you can see that you actually test against like all kinds of validation. Like, am I actually like limiting how long things are, limiting data in any sort? Like, it can go on forever. These are just the first 10 cases, and the way property testing works is that, especially with this library too, I think with all of them, is that they get larger as they go. So you can imagine like huge sets of things that you're testing against, and actually we found a lot of bugs. So in a more, I guess, explicit example of it, for example, we have this hash map one here. Like all our schema declarations are like this, because we're talking about JSON, right? So we're basically like, kind of like JSON schema, we're talking about JSON. So if I'm going to have a foo key, I'm going to have an optional key here, I have this Midwest.io, I have a baz, I have a bar. Our bar points to the schema for the vector that we just had. So we can use schemas all the time. You can actually do recursive schemas as well. We actually have regex right here. So it's like you might have something where it has to fit the certain regex. And then again, I have like, this could be the repeated value of keywords and numbers. So I'm going to sample this up. And I do. And we're basically getting all this data. You're seeing that bar, which is to the schema definition that I did before. That's showcasing all that as well. So I can generate hundreds and hundreds and hundreds of these to make sure that our implementation is right, that we're dealing with all the fields that we need to deal with, and that our validation layer is correct as well, which is probably the most important thing before anything hits the database. Okay, so just to show you a little bit about how this library works, I think we're talking about the Julia talk earlier about multiple dispatch. Clojure had its own variation on multiple dispatches. I really like. And this is how the library schema gen that we do. So, schema under the hood, we just match on these schema types. So we have sbool is a Boolean, of course. So it's just a generator of either a true or false element. The maybe one is a different one. It's a class under the hood. So you see that I have an identity in class right here. That's what I'm matching on. So here I can say that maybe, when it comes through as a schema definition, is one of either nil or itself a generator. So then I can have generators within generators. And then this is like a big one here. So actually I use, Clojure has two kinds of, has a persistent array map and a persistent hash map. I wanted them to work the same for our case. So I use what they call like a hierarchical stuff here. So I have the gen map key right here. So I can match against those. And this gets a little more complex, where I separate out all the required keys from the schema and the rest. And then from the rest, I get what are optional and what are repeated. And then we have this apply by thing. This is the kind of fun thing, actually, and I was going to talk about it later, but we're starting to use just the generators from test.check to generate data for like a mock database for some of the clients. So I'm not even testing for all of it. I just like the idea of composing all these generators that I'm giving constraints to, and they're automatically generating data. I think it's a really fun thing. So in this case here, the apply by function, that's just what I showed it earlier where I made everything in the vector evens. This is just what they call an fmap. So the fmap is just applying itself over to say, apply a function over a generated set of data. So I'm applying, in this case, partial apply merge, and I'm merging all these sets of data, which I'm using, hitting on a required and optional right here. So this is just a little example of the library. It's open source, and any work, I think any of me or the people on Prismatic and stuff would love any help required. There's still a lot more types that are a little bit harder to deal with, and I'll talk about why. We deal with them specific to our use case, which I'll talk about in the case study, but it's hard to make them more generic for everything. All right, so case study. So yeah, I work at a company. We're doing web services, closure at scale, and we're using Prismatic, right? So if you think of the thing I was talking about earlier about property-based testing, we're talking about, do our web services work? There's, the pretty basic example, and these are pretty basic, is if I get a bunch of results and I pick one and I update a bunch of it, but not all of it even, and then I put it back, I should be able to get it later, and it should be exactly the way I wanted it when I added all that stuff. It's a very simple case. Web services, how they work. Boring stuff. This is not cool. I mean, it's cool. The cool part is the testing, actually. The testing is really cool, and obviously the products are cool. But the layer of services, but you would imagine for all this stuff that's not that interesting, how you deal with JSON back and forth. Why? There's so many bugs. You go on every website, there's so many bugs, or the APIs have bugs, and why? Because the more data you have, the larger these designs get, or the more changing they do, failure will occur, you will have bugs, and you still want to be able to do this. I don't want to sit there maintaining this stuff later. I probably will anyway. But I don't want to sit there forever having this, always try out new tests or write these small little tests that are never going to work for the long scheme. And I think property-based testing works for the long scheme. Okay, so when I was thinking about a specification and how I wanted to test against this for our system, I created a macro, which is in itself like, macros, if anyone knows about macros, there's a lot to them, but in one way, they're kind of like a little DSL that you can use for specific things. And what I have here is a generator macro, which calls that prop for all. So we're actually doing a generator for all, and it's going to do all these things inside of it. I'm bringing this system, which is our little bit of state that we actually have here, which is configuration details. So what I'm doing here is I'm generating the schema from something called a resource gen. I'll say what that is later. That's our specific use case where we can add customized generators to the ones output by the schema. So for all these tests, we generate data, and then I go through all this configuration stuff, and then I first validate. Using schema's validation properties, I say, first validate the generated data matches schema, which it should because I generated most of it from there, so it should. Yes, it does. Okay. Next use case, I make a put request. Make sure in the put request, make sure it works. Make sure I get a 200. That should definitely work. If not, stop everything. Don't run through the whole test. When I get the put response back, which is we have different representations for what we post and versus what we put. They're different. I have to make sure that the put response here also validates against schema, that what comes back from it is exactly what it should be. And most of the time it does. Now, if it doesn't, this is the beauty of the shrinking and everything that I talked about before. When we go a little further ahead, we make sure when you make a new get on that same thing, you go in the database, which is like a different representation. Do I get back the same thing? And we do. So this is my specification, that this basic system of JSON web APIs should work this way and should always give you the right data. It should always take in the right data. Otherwise, fail. And we use this, and I can run this over, we have 9 resources or whatnot, and I can, our tests went from having like a total over the 9 resources, like 300 tests to, I forget the number of tests, but the number of assertions now are almost in the 4,000s. It's good to see as one thing, but also we definitely see we're adding new features, and people just get their implementation up and running. They're like, oh, it's just going to work. They haven't written their generative tests for their feature yet, or their certain resource. But because it has relationships with other resources, things are failing in here, and it's like, well, it's actually because your implementation doesn't work. So that's good. It finds bugs. I can't lie. So what we do to handle our case, so I showed you the schema stuff earlier. Those are pretty basic types, things like maybes, things like optionals, and all the basics like ints, numbers, keywords, and regular expressions. But we have to do something very specific because we have a lot of, our design's changing constantly, and there's certain stuff where we have to create our own arbitrary generators. And that's what we do here. So for example, like biography is a localized map. That is a schema, is basically like, :en, English language, and then the biography in English, and then FR, French, right? So it goes down that list. It's a little hard to actually generate every possibility that would exist for that. So we write our own customized generator. Actually, a coworker of mine wrote a library for schema called Schema Contrib that does stuff for languages and countries. So what this does is that we have a little system where we basically take. So I have all these here. I have some customized stuff here. This is the schema itself. And then here I actually have the customized generator. Sorry, here. So biography is a localized map generator. So I have these. We can actually remove certain fields because we actually, in our test, can like randomly remove certain fields that we don't want. We're testing against things not being there. Or if you make a put response, we want to say keep some of those fields. Like created at is never going to change. So keep that in. And so we can do that. We can remove that from generation. And we also deal with a lot of relationships, big joins across things where it's like this thing is related to that. And I can't really completely generate that data yet. We have some ideas of how we want to do that. But for right now, I allow it where I can inject in specific sets of relationships that it randomly chooses from. So then we have this function called generate, which is like a multi-pass generator, which takes in the customized generators in the schema, and we'll just do a 2-pass kind of walkthrough where it first does some cleanup, then generates the initial set of data from schema. And then you see here we have this fmap, and the fmap just applies another set of functions to basically merge in all the new customized generators with that original set of generated data. So we're allowed to basically say we can have custom generators, we can have our type-based converted generators, and we can mix it all together with some special little hints that we have at the top, which this does, and go test that. That's more to our specific domain. This is why this is not like a separate package right now, because it's like this is more specific to our data and how our data works. But actually, once you have something like this running, everything works this way. We use the same generate method for all resources that we deal with. It just goes along nicely. Okay, so like a live demo of what we do, how we normally run tests. This is going to be fun. Okay, so so I have let me actually switch this over. Sure, the right thing. There we go. Okay, so I have a VM up, which is even another bad idea for a demo. But I have a VM up here. I'm going to test one of our things. I just want to show you some of the data, the requests that get created from our set of generators. So hopefully it won't take too long to run up. But you can already see I've been actually running this to make sure it does work. So you look over there where you see the info right there, because I'm just printing everything, logging everything out right now. All that stuff is generated. So if it's hard to even see here, but if you look at images, foo, size, 50-50, it's just constantly generating these things. And here we go. JVM, guys. It's very slow start time. Okay, so... All right, so as you see it's huge, something really huge, right? So that was really great. Let's go back while that's going. That's great. That is a generated set of data. There might, I know all this stuff works now because I'm running off master, right? So it should be working. But ideally, this, if there's an edge case to find, this will probably find it. So it's a lot of stuff in here. And they can be small. That's great. It's a great example. Thank you. Thank you for running it that way. So that shows you how awesome and how great these things can be. And we run this on everything. The test, the one thing is when you run these property-based tests, speed is not what you're looking for. There is an XKCD, I think, where it's like I'm testing, or I think it's compiling, but now we move to testing, right? Because who compiles? Joking. You run out, and we let it test for a while, and it goes. They do take a while. We're working on some stuff to specifically hit them just at a namespace that we can just put in a config to run those tests on our main merges. But nonetheless, you get the sense here where you're starting to see lots of data, lots of stuff being done. And the more we can do, the things that we want to do for the schema gen library, as well as the stuff we're trying to do internally, is how can we make things more hint-based and add more constraints? This is probably only mocking out, 75% of our data, when the next 25 is like the hard part, when there's a lot of relationships involved, and how can we make that better and more generic? We can use that within the library. So we're trying to do that now, and unfortunately, don't get that much time. There's enough time just to get tests, and we're getting the tests in. But as a library, the schema gen thing, we're trying to think more about that. Okay, if I can move back. Nice. Okay. All right. So yeah, there's other uses. Sample data population is something that we've been using it for as well. I think that's great. I mean, again, I like functional programming and ability to create these generators and apply all these conditions to them in a chain-like way is really great. Query parameter generation, so we just started doing this. I work on the search team now. We're still doing some Elasticsearch. So we're like, we have a lot of filters and a lot of things you can search by. So we're actually just using this to generate parameter sequences for our calls, just to do a bunch of them for us, because we're lazy. That's exactly where it goes down to. Additionally, we started doing this and I wanted to show an example, I couldn't get it in time, is we're actually, talk about the invariance. Like the invariance is that it doesn't change, so that could be always true. We're always testing this is our specification true. But we can actually use it to say, we know our specification is false, and then check if our error checking is right. So that's really great too, and that's actually probably more important to the clients than anybody else, because they're working on these apps on the services, and they're like, I don't understand this error at all. And it's like, well, neither do we, so we have to figure it out. And then, so working on the Elasticsearch, slowly thinking about and mocking out some idea to actually generate sets of data to search against, and then do tests to make sure the scoring seems somewhat consistent. So you can actually see if your scoring algorithms actually applies across different sets of data the right way. That's pretty good as well. So some stuff we're looking at. I think that's very interesting, actually. I think for Elasticsearch, it'd be really great. There is some other work being done now with, that I've looked at as well. If you want like more typiness, there is core typed, which is really cool. I have not played with it much at all. There's actually a library that someone has written that converts schema, prismatic schema types to core typed, which is really interesting. I've been wanting to actually pass all our stuff through that. And obviously, having the ability to generate from core type, I think could actually solve a lot of those issues with the more heavily constraint-based types or more complex things you're dealing with in your data. Okay, so I'm ending a little early, which is good, so time for questions. But there's a conclusion. So like when I saw John Hughes talk, which I recommend, he has a couple videos up. He's a great speaker, and his whole thing was, don't write tests, generate them. And I highly recommend it, because I hate writing tests, and I'm not saying you can completely throw that out. So you still have to, you can't just do it one way or the other. It's good to use both. You have more tools in your set. But by generating them, you get so much more, and actually, it's opened up my ideas. Like, as I've been hammocking about all the various things that we can do with generators that I showed in the previous slide, you can imagine what you can do, all the things you can do, and there's more there, and there's more, there's less blind-driven development. I think it gives you more thought, and more thought usually makes better code. So, thank you. So, any questions?
Yeah. I got to the mic first, so I guess I win.
Nice.
So do you find you're using Prismatic schema, do you use it top and down through your code base, or you tend to use it on the edges when you want to use generate tests?
Since we're doing service infrastructure stuff, we use it for everything. Okay. Yeah, I mean, I myself also like type languages and that, and the schema doesn't give you completely that, but it gives you a little bit of that concept. But I like that we can just keep it in its own separate namespace, and we can just bring in certain validation functions when we need it. But I find it very useful, and they've done a lot of great work to explore more complex validation principles.
Great. Thanks.
Hey, thanks for the talk. One question I had was, how do you build confidence that the invariants that you are specifying are actually the right ones that you want to test?
Good point. At the end of the day, I mean, the one thing is, you have to know your kind of client stories and the people that are using it. At the end, I still think there are holes in our code, and I know there are. But feature-driven development, is the way to go. But no, I think the confidence that comes up is that when I first, I got like a week to implement a lot of what is now. So I did, and what was in master completely passing tests, I think we found like over 60 failures. And that was a good reason to be like, hey guys, we're not doing things the right way. And here's how we can fix it. And actually, I think it doesn't give me the utmost confidence still. There still could be more, because there's more we can do with the generators to define more edge cases. But it definitely makes me feel more comfortable. I know everyone on the team I work with feels more comfortable after the 5 to 10 minutes this runs, and it works. So, and that it finds new things as people write anything that deals with relationships. So we talk about the idea of like having the right test for multiple features. So as we're adding new things, we're always dealing with, is it going to regress the old things? And this actually will always find it, because it's constantly generating data again and again. It never stops. So, anybody else? All right. Thank you, guys.